This new chapter comes with some introduction. Chapter 4, Aqueous Solution Chemistry, possibly the most important chapter in this course. So to start off, some questions for you. Why is water a good conductor of electricity? It's kind of like a late night talk show. There's no audience. Anyway, what is a strong electrolyte? What is a weak electrolyte? Those are the answers you'll have once we finish this chapter. If someone has a single arrow or if someone has a double arrow, does that mean the exact same thing? It does not. Are these identical equations? Oh, you see three of them. You see some HCl, some sodium hydroxide, some water, some NaCl. They're the three different forms you're going to be learning to write to talk about what happens with aqueous solutions. So they are the same, but they are not the same. We'll get into the details in a moment. How does iron 2 enter your cell? That's probably more exciting than anything I have to say, and that's going to come up a little bit later in the chapter. And our molarity, the capital M, and molality, the exact same thing. They are not. How does a blood alcohol test work? That'll be the problem of work is the last one in this chapter. So, what is in your blood? Well, there's many different things as you can see from this picture, but what I want you to look at is what are the units? We have micro, we have milli, we have deca, we have nano. That is why you had chapter 1, to see, so you could see what do they really mean in terms of magnitudes of 10. The other thing I want to stress is that protocols are employed in the real world. They have to be vetted for accuracy and precision. Right now we're going through the coronavirus testing, and as you know, results are very mixed depending on the test and who does the test. So again, very, very much real world. The thing up here is really the blood alcohol old-fashioned tester. Now they tend to hold a flashlight in your face which has a sensor. Okay, so again, you can read through this. These are the assigned homework problems. Let's get started with Arrhenius. In 1903, he won the Nobel Prize in Chemistry, but in 1884, he proposed that ionic compounds separate into oppositely charged ions. And look what I wrote next. His advisors were not impressed. He received the lowest passing grade. Why didn't scientists believe this in 1884? Well, if you had sodium and you threw it into water, it would burst into flames. I shall admit as an undergrad, we throw sodium off a bridge. That was a long, long time ago and watched it burst into flames. Chlorine was a poisonous gas. When it was inhaled, it would go in your lungs and make hydrochloric acid, which did not have a very positive result. So what's in this chapter? Aqueous solution properties are the first section, and this is something that students struggle with, okay? So when we say a solution in our class, we mean one that is in water. Our solvent is the item in the greater quantity, water, and our solute is what we put into it, the smaller quantity. So as a mom, I have made a lot of Kool-Aid. I don't think people make that anymore, but water was what you would dilute the little packet and sugar with, and here we have some sugar. Now, the two terms to really focus on here, one of them is electrolytes, and they dissolve in water to give an electrically conductive solution. Sodium solid in water gives sodium cations and chloride anions. If I have a non-electrolyte, my solid is going to dissolve in water, but it's going to give a non-conductive solution. And as you see, there are no ions, okay? So how can you decide on what kind of solid you have? Well, if you have a light bulb and you have a solution and you have some leads, you can actually see visually. This is pure water, very pure water. You see the light bulb is not lit. But if I pour some sodium chloride into the water, all of a sudden we see a very bright bulb. And that bulb is because that sodium chloride is an electrolyte, and we are making sodium ions and chloride ions in water. Same things that flow in your bloodstream, sodium, potassium, and calcium for ion channels. What if instead we put sugar into water, sucrose? This will be not lit because there are no ions. It does not conduct electricity. Notice the contrast, how I've written these. The molecule has stayed together. The ions have fallen apart from the sodium chloride. So, ions conduct electricity. They are not formed. They already exist in a lattice, and that will be in chapter 12. But when a solids dissolve, when you put them into water, the ions become free to move in water. This picture shows the sodium chloride solid lattice. And as you see, there are little things coming off of it. This would be the chloride ion surrounded by water. This would be the sodium ion surrounded by water. And because those ions are present in solution, we are able to have conductivity. Notice there is a line in between the two. Don't cross the line. The line on the right-hand side says molecular solutions. I'll say the structure of methanol, CH3OH. All of the species are nonmetals, and when a molecule dissolves in water, it does not form any ions. We'll talk about that in 1220 in chapter 13. So as you can see, you're getting information here, not a lot, but what you want to do is pick up the difference between something that is ionic and makes ions and something is molecular and has no ions whatsoever. So it's in section 4.1. We want to teach you to write the equations that you will use later in this chapter. There are two types of electrolytes. One of them is strong, and strong, it will exist completely or nearly completely as ions. We always use a single arrow. So I would complete this equation, and if we had paper quizzes, so would you on a quiz, Na plus and Cl minus. HCl gas would make H plus aqueous and Cl minus aqueous. Something like a base sodium hydroxide would make Na plus and OH minus aqueous. To be memorized, to be understood, to be used as we work our way through Gen Chem. That's a strong electrolyte. What we also have are weak electrolytes. And they're almost always a neutral molecule. And you're going to say, wait, molecule is a non-electrolyte. No, there are some materials that are weak electrolytes. This is vinegar. It is part of Italian salad dressing. And when you put vinegar into water, what you get is CH3CO2 minus aqueous, and you get a little bit of H plus. So that little bit of H plus, it says this is a weak acid. You have stomach acid, HCl, a strong acid that stays in your stomach to digest your food, but you can eat something with vinegar because that is a weak acid, and we do that with the double arrow, and that is because the ions can recombine. Now, ammonia is a weak base, and in order to write an equation, we have to include water. The other half of this equation is NH4 plus and OH minus. Those of you that had those really strict, hated high school teachers, they forced you to memorize these things, and now this will come in handy. For all the weak teachers you had, you got a hard path to hoe. It's just going to be kind of uphill. But strong electrolytes and weak electrolytes. Now, part of what we do in Gen Chem is we tell you a little bit at a time. But I want to also mention to you the exceptions. Calcium carbonate are seashells on the beach. And as you know, they really do not dissolve. But you can still write an equation because ions do form. For those of you that have had KSP equilibrium, we're going to cover that in 1220, the K for this is always much, much less than 1. So this is really electrolytes, okay? As I go to the next picture, it really is from different parts of different courses. When you're going to be in Chemistry 1220, we're going to talk about these hydrated ions again when we talk about solubility. Hydration really means a coating of water. This is the chloride ion, this is the sodium ion, and they are hydrated because they are not naked. They are surrounded by waters. How many depends on how big things are, okay? The other thing, if you are doing anything in biochem, anything in medicine, when you have an enzyme substrate reaction, the substrate is surrounded by water molecules, the enzyme is surrounded by water molecules. And in order for a reaction to occur, you must cause disorder and have these two things come together. Again, these are from other courses, but what we want to make sure you get in this course are cations and anions conduct electricity. Things like C6H12O6 that are molecules, they are non-electrolytes, and these ones make ions.